Section 4.1 Basic Set Operations and Venn Diagrams. We continue with the definition of the universal set. The universal set is the set of all elements under consideration. We denote the universal set with a rectangle. Right here is the rectangle. And we use in general the letter U and the subsets as closed loops. And this is a closed loop. And we can use any letter to denote the subsets. I'm going to use A. We use these Venn diagrams to illustrate the basic set operations. I'm going to assume that A has two elements, X and Y, and then we have a third element out here, Z. So as we can see, U has three elements, X, Y, and Z. A, the subset A, has only two elements, X and Y. So we can write that as X belongs to A and X belongs to U. X it's part of both the universal set and the subset A. But Z doesn't belong to A, it's not part of A, but Z, it's part of U. We continue with the union of sets. The union of sets A and B, written A union B, is the set of elements that are in set A or set B or in both sets. If we look at the Venn diagram here, we have the universal set U, we have the set A, the set B, and I'm going to highlight the union of the two sets. As it says in the definition, an element X belongs to A or X belongs to B. So to highlight the union of the sets A and B, I take all the elements in A and B without repeating. So think of union as combining the two sets. Remember, order does not matter in a set and we do not repeat elements. Next, let's talk about the intersection of sets. The intersection of sets A and B, written A intersection B, it's the set of elements common to both set A and set B. A intersection B equals the element X such that X belongs to A and X belongs to B. Let's look at the Venn diagram. We have U, the rectangle, the universal set. The first circle represents set A. The second circle represents set B. The intersection. Think of intersection as finding the elements the two sets share, what they have in common. Let's highlight the intersection of the sets A and B. It's the part where the two circles intersect. This is the intersection of sets A and B. Now let's talk about disjoint sets. If two sets have no elements in common, they are said to be disjoint. The intersection of two sets A and B that are disjoint, it's the empty set. As you can see here, the sets A and B do not overlap, they have nothing in common. Now let's continue with the complement of a set. The complement of set A, written A prime, it's the set of all elements in the universal set that are not in A. A prime equals X such that X belongs to U and X does not belong to A. Using the Venn diagram, I will show the complement of A. First, let's denote the sets. The rectangle represents the universal set U. The first circle is going to be set A. The second circle is going to be set B. Think of the complement of set A as everything in U except set A. So I'm going to start marking everything in U except set A. So I'm going to go around set A and marking everything. The last definition, cardinality. The number of elements in a set A, it's called the cardinality of the set, and it's denoted by n of A.